Hello students, in this video we are going to study Chemical Kinetics. This is unit 4 of class 12th. Whenever any chemical reaction occurs, then there are mainly three aspects. The first one, whether the reaction at all take place or not. That means this reaction is spontaneous or not. It can be discussed in the terms of Gibbs energy of thermodynamics. Secondly, if it is spontaneous, then to what extent the reaction take place before equilibrium to attain. That means this aspect can be discussed under chemical equilibrium. And finally, rates or speed of reaction, which the branch of thermodynamics is unable to answer. Right? So the branch of chemistry which deals with the study of speeds or the rate of chemical reaction, the factor affecting the rate of reaction, and the mechanism by which the reaction proceed is known as chemical kinetics. So in other words, simply we can say chemistry is the branch of science which deals with the chemical reactions. तो जब भी कोई केमिकल रिएक्शन होता है देन देयर इज़ अ बेसिकली थ्री एस्पेक्ट. फर्स्ट ऑफ ऑल कि ये रिएक्शन स्पॉन्टेनियस होगा या नहीं होगा, मतलब ये रिएक्शन वेदर अपने आप हो रहा है या फिर हमें इसके लिए कुछ एफर्ट डालना होता है. राइट, देयर आर एक्चुअली टू टाइप ऑफ रिएक्शन, स्पॉन्टेनियस एंड नॉन स्पॉन्टेनियस, जिसको हम लोग हिंदी में स्वतः और असवतः बोलते हैं. यानी कि जो अपने आप होता है दैट इज़ कॉल्ड स्पॉन्टेनियस, और जो अपने आप नहीं होता इज़ नोन एज नॉन स्पॉन्टेनियस. सेकेंड एस्पेक्ट इज़ दैट, जो दूसरा पॉइंट है वो ये है कि क्या ये रिएक्शन अगर ये स्पॉन्टेनियस है देन ये रिएक्शन बिफोर कंप्लीशन इक्विलिब्रियम तक जाएगा या नहीं जाएगा. एंड दिस टॉपिक इज़ डिस्कस्ड अंडर केमिकल इक्विलिब्रियम. एंड फाइनली द मोस्ट इम्पॉर्टेंटली कि जो भी रिएक्शन है इसकी स्पीड या रेट कितना होगा. बट दिस क्वेश्चन इज़ नॉट आंसर्ड बाय थर्मोडाइनमिक्स. जो ब्रांच है थर्मोडाइनमिक्स की, उससे हमको इसका आंसर नहीं मिलता कि व्हाट विल बी द रेट ऑफ द रिएक्शन. सो पर्टिकुलरली the branch of chemistry which deals with the study of speed, the rate of chemical reactions, and factor affecting the rate of reaction, and the mechanism by which the reactions proceed is known as chemical kinetics. So what we have to study under chemical kinetics? First of all, we have to study the rate of chemical reaction. Secondly, what are the factors which are going to affect the rate of reaction, and finally and most importantly, mechanism of the reaction. So there are basically two types of reactions. The first one are very fast reaction. So what happens in very fast reaction? These reaction take place instantly, means ये बहुत जल्दी complete हो जाते हैं. And time taken is generally 10 to the power minus 12 to 10 to the power minus 16 second. Let me write here 10 to the power minus 12 to 10 to the power minus 16 सेकेंड्स में ये रिएक्शन कंप्लीट हो जाते हैं. दे आर नोन एज वेरी फास्ट रिएक्शन एंड जनरली ऑल आयोनिक रिएक्शंस आर कम्स अंडर दिस कैटेगरी. फॉर एग्जाम्पली, सपोज वी रिएक्ट सिल्वर नाइट्रेट, aqueous solution of silver nitrate with sodium chloride, then the reaction will be very fast and it form silver chloride and sodium nitrate. So these kind of reaction are known as fast reaction, very fast reaction. The second category is very slow reaction. Very slow reactions are those reactions which may take very long time, days or months, like rusting of iron. And third category, which is very important from the point of view chemical kinetics, moderate speed reaction. The examples are hydrolysis of ethyl acetate, hydrolysis of sucrose, decomposition of ammonium nitrate, decomposition of hydrogen peroxide, etc. So these are the reaction which are not too fast or not too slow. So under chemical kinetics we mainly considered these kind of reaction, means whose speed is moderate. They are neither very fast nor very slow. So this classification was based on the rate of reaction. So यहाँ पे तीन कैटेगरी ली हमने. द फर्स्ट वन क्या है? वेरी फास्ट रिएक्शन जो बहुत तेज़ी से होती है. सेकंड वेरी स्लो रिएक्शन जो कि बहुत स्लो है. सो ये दोनों ही कंडीशन में स्पीड कैलकुलेट करने का कोई मतलब नहीं है. ठीक है, तो हम क्या करते हैं, जो थर्ड कैटेगरी है दैट इज़ नोन एज मॉडरेट स्पीड रिएक्शन, हम उसी को कंसीडर यहाँ पर करते हैं. द Next one is, what is the rate of reaction? Now question is arises कि rate of reaction क्या होता है? So rate of reaction is the change in the concentration of any one of the reactant or products per unit time, right? Means actually what happens, ये मैं आप लोगों को explain करती हूँ, let me know. देखो, a typical reaction, reactant to product. Then what happens, initially the concentration of reactant is maximum, suppose it's x, and the concentration of product is 0. अभी reaction start नहीं हुआ है, so only there are presence of reactant, so its concentration will be maximum, and products अभी बने नहीं हैं, that's why concentration of product will be 0. अब जैसे जैसे टाइम स्लॉट आगे बढ़ता जाता है, देन concentration of x decreases. कैसा होता जाएगा? With time period it will be decreases, and the concentration of product will increases. So ये जो बढ़ता हुआ ग्राफ है that is of product, and जो ये डाउन होने वाला ग्राफ है that is of reactant. This graph is drawn between time and concentration. Okay, so we can take any one reactant or any one product, and the change in the concentration can be calculated, and that will be the rate of reaction. If the concentration is changing very fast, then it is fast reaction. If concentration is changing very slow, then it is slow reaction, and if the concentration changes in moderate range, then it will be moderate reaction. Okay, yes. So here we can see, for hypothetical reaction, reactant is changing into product, rate of reaction is decrease in the concentration of reactant divided by time interval, or in other words we can say increase in the concentration of product divided by time interval. Both will be same because both are complementary. जितना reactant decrease होगा उतना ही product appear हो जाएगा. So that's why both are equal. So we can calculate the rate of reaction by using this formula or by using this one. Suppose R1 and P1 represent the molar concentration of reactant and product respectively at time T1, and R2 and P2 are their respective concentration at time T2. Then change in the concentration of reactant will be, क्या करेंगे हम, R2 minus R1 and here P2 minus P1. It is represented by del R and del P. ये जो triangle का जो symbol है, this represent actually change, right? Then time interval will also be T2 minus T1. So we can write here rate of reaction will be equal to minus del R upon del T, which is equal to plus del P upon del T. Now here there are sign plus and minus. So what is the significance of plus and minus sign? ये numeric value के minus या plus से इसका relation नहीं है. It just shows that कि reactant, the concentration of reactant is decreasing. That's why we here mention minus sign, and the concentration of product is increasing. That's why we are using plus sign. So plus and minus sign along with this term is used for their increase or decrease. हम सिर्फ उसी के लिए ही यूज करते हैं, राइट? फॉर एग्जाम्पल यहाँ पे एक एग्जाम्पल कंसीडर किया है. द रिएक्शन इज डिकम्पोजिशन ऑफ फॉस्फोरस पेंटाक्लोराइड. फॉस्फोरस पेंटाक्लोराइड इज गोइंग टू डिसोशिएट इनटू फॉस्फोरस ट्राइक्लोराइड एंड क्लोरीन गैस. सो दिस इज आवर रिएक्टेंट and these are the product. So there will be change in concentration of phosphorus chloride. It will continuously decrease. That's why we take the sign minus. यहाँ पे एक माइनस साइन क्यों लिया? बिकॉज फॉस्फोरस पेंटाक्लोराइड का जो कंसेंट्रेशन है वो कंटिन्यूसली क्या होगा? डिक्रीज होगा. वेयर एज द कॉन्सेंट्रेशन ऑफ फॉस्फोरस ट्राइक्लोराइड एंड क्लोरीन विल इंक्रीज कंटिन्यूसली. तो जब भी आप इसको ऐसे स्क्वायर ब्रैकेट में शो करते हो, राइट, देन इट मीन्स इट इज़ रिप्रेजेंटिंग इट्स मोलार कंसेंट्रेशन. सो आपको ये स्क्वायर ब्रैकेट यूज़ करना बहुत नेसेसरी है. ओके, सो यहाँ पे हम लोग देख रहे हैं कि फॉस्फोरस पेंटाक्लोराइड del PCl5 divided by del T, which is equal to plus del PCl3 upon del T, which is equal to del chlorine upon del T. That means concentration of chlorine upon del T, concentration of phosphorus chloride upon del T and concentration of phosphorus pentoxide is equal to del T. So यहाँ पे क्या हो रहा है कि reactant decrease होते जा रहा है, that's why यहाँ पे minus sign लिया, but products are increasing, that's why here plus sign. So in general we can represent the reaction like this: A plus B is equal to C plus D. It's a general representation of a typical chemical reaction. So what will be the unit of rate of reaction? Since concentration is generally expressed in mole per liter and time taken in a second and minute, that's why its unit will be moles per liter per second or moles per liter per minute. In case of gaseous reactant, pressure are used in place of molar concentration. That's why as pressures are expressed in atmospheres, therefore the unit of rate of reaction are atm per minute or atm per second. So these are the units. Now the next topic, average rate and instantaneous rate of reaction. A difficulty arises in stating that the rate of reaction as above. Here we discuss the rate of reaction. What we discuss that the change in the concentration of reactant or product is known as rate of reaction. ये हमने पिछली स्लाइड्स में जस्ट अभी डिस्कस किया, बट प्रैक्टिकली इट्स नॉट लाइक दैट. इतना ईजी नहीं होता है. वाई? बिकॉज अकॉर्डिंग टू लॉ ऑफ मास एक्शन द रेट ऑफ रिएक्शन डिपेंड्स अपॉन द मोलार concentration of reactant which keep on decreasing with the passage of time while those of product keep on increasing. Hence the rate of reaction do not remain constant throughout the reaction. So problem is that कि concentration of product is not concentration of reactant is not constant throughout the reaction. Means मैंने आप लोगों को ग्राफ से अभी एक्सप्लेन किया था that कि concentration of reactant is going to decrease continuously. So rate of reaction is directly affected by concentration. So if concentration is decreasing, then definitely rate of reaction is also going to decrease. So overall the reaction rate of reaction is not constant throughout the reaction. In this way the rate of reaction is defined as above is average rate of reaction during the time interval chosen. तो हम जो भी rate of reaction actually count कर रहे हैं that is average rate of reaction होता है. Because what we chosen, हमने क्या किया, we are taking just time interval. Means suppose 5 minute and 15 minute. So we are taking the time interval of 10 minutes. हमने 10 minutes का time interval लिया. So concentration at 5 minute and concentration at 15 minute, ये दोनों को हमने क्या किया, del molar, I mean molar change in molar concentration निकाल लिया from time 5 minute to 15 minute and divided by हम उसको क्या करेंगे 10. That means हम क्या ले रहे हैं वहाँ पे, average rate ले रहे हैं, because the rate of reaction is changing in every second. ये continuously change हो रहा है. So that's why it is considered as average rate of reaction. So how can we define the average rate of reaction? तो यही हुआ जो हम normally calculate करते हैं. That means this one, जो भी हम अभी ये लास्ट स्लाइड में भी जो हम ये निकाल रहे थे ना, these are actually average rate of reaction. So what about instantaneous rate of reaction? Instantaneous rate of reaction is the rate of reaction at any instant of time, right? So the rate of change of concentration of any one of reactant or product at a particular instant of time. Actually average rate of reaction and instantaneous rate of reaction both are same. The change is only here. यहाँ पे आप देखो representation में, there we are using del means जो ट्रायंगल का एक शेप बना हुआ था वो, बट हियर वी आर रिप्लेसिंग दैट डेल बाय डी. हम यहाँ पे क्या ले रहे हैं, देखो आप लास्ट स्लाइड में हमने देखा था कि यहाँ पे सब जगह पे क्या था, डेल बना हुआ था, बट हियर इट्स ओनली डी. ओके, सो यहाँ पे ये जो डेल और डी का क्या फ़र्क है कि डेल जो है वो एक बड़े टाइम इंटरवल को शो करता है, लेकिन जो डी है इट शोज़ द स्मॉल चेंजेस. सो टू एक्सप्रेस instantaneous rate of reaction, a small interval of time is chosen at that particular instant of time during which the rate of reaction is supposed to be almost constant. अभी हमने टाइम इंटरवल क्या किया, बहुत कम कर दिया. So rate of reaction will be almost constant, and here del t is limiting to 0, मीन्स आपको टाइम इंटरवल इतना कम रखना है कि ये अप्रॉक्सीमेटली और नियर टू क्या रहे, 0 रहे. सो एट दैट कंडीशन द रेट ऑफ रिएक्शन इज नोन एज इंस्टेंटेनियस रेट ऑफ रिएक्शन. सो हाउ कैन वी एक्सप्रेस द रेट ऑफ रिएक्शन इन टर्म्स ऑफ डिफरेंट रिएक्टेंट्स. अब जिसके पहले जो हमने रिएक्शन लिया दैट वाज अ सिंपल रिएक्शन एंड देयर इज अ इन्वॉल्वेशन ऑफ ओनली वन मॉलिक्यूल, बट हियर 2N2O5 गिव्स 4NO2 प्लस O2. तो अब यहाँ पे ये जो चेंजेस आ रहे हैं मीन्स द नंबर ऑफ मॉलिक्यूल हियर इज़ 4 एंड द नंबर ऑफ मॉलिक्यूल हियर इज़ 2. सो एट दैट कंडीशन हमको ये रेट ऑफ रिएक्शन कैसे लिखना है ये देखते हैं. फॉर दिस रिएक्शन रेट ऑफ डिकम्पोजिशन ऑफ N2O5 हम नॉर्मली ऐसा लिख सकते हैं इसको D molar concentration of N2O5 divided by dt. Here we are using D, that means it's showing instantaneous rate of reaction. Similarly in case of NO2 it is the rate of formation and this is the rate of formation of oxygen, but we have to consider its number of molecule also. It's disappearing, N2O5 is disappearing, so its rate of concentration is continuously going to decrease. So if there are two number of N2O5 then we have to take this 1 by 2. 4 number of NO2 is appearing then we have to take 1 by 4, and there is only one number of oxygen is there, so it's as it is. Similarly here 3 hydrogen atoms are involving, here 2 ammonium atoms are molecules are involving, so it will be written as 1 by 3 and here it will be 1 by 2. Okay, so this is the method of expression, and for this also it will be 1 by 5, it will be as it is, it will be 1 by 6. So these are the reactant, तो कौन सा साइन यूज़ करेंगे, माइनस, but these are the product, 3 bromine, 3 water molecule are there, so it will be minus, it will be plus because they are the product, so it will be 1 by 3 and 1 by 3 in case of water also. So in general we can express any reaction as like this, ऐसे हम इसको express कर सकते हैं. So for today that's all. In the next video we will study the factors affecting rate of